Welcome to our Huawei Next Generation AR Router launch webinar. I'd just like to remind you before we start that you can submit questions during the presentation. We will take the top 10 questions, and we will give an award to the people that offer the most insightful or interesting question. There will also be a quiz at the end of the webinar, and for those that answer the most complete and correct answers, you will be eligible to win a Huawei prize. My name is Michael McDonald, and I am the Chief Digital Officer for our Southeast Asia region. You can certainly contact me at any time through any of the Huawei channels or our Huawei colleagues. So today we're here to launch the Huawei Next Generation Router series, but before we do that, let's talk a little bit about SD-WAN in the addressable market. If we look at some survey results from IDC, we see that 57% of enterprises are expecting to deploy an SD-WAN solution in the next 12 to 24 months. That's a survey based on over 1,200 enterprises worldwide. If we look at Gartner's definition of what SD-WAN encompasses, there are four key facets. The first, it must support multiple connection types. That means traditional technologies, layer 2, layer 3, MPLS, internet access, and even some of the newer technologies like LTE. It needs to be able to support dynamic link adjustment. And in order to do that, we need to be able to recognize different applications and process them correctly. Third, it has to have simple management. It needs to be easy to deploy, easy to configure for your standard IT manager. And fourth, it should support the ability to have value-added services. This could be web optimization, firewalling, or even things like a SIP access gateway. If we start today with SD-WAN routing, traditional routers are really built in a world based on layer 2 and layer 3. They lack the processing capability to look beyond at layer 4 and above. They excelled at simple routing, movement of packets, but they were not able to identify individual applications or certainly not take advantage of maximizing bandwidth capabilities. SD-WAN introduces new elements to the equation, and what allows us to do this is we decouple the control plane from the actual data plane. By doing so, we can alleviate a lot of the processing requirements in the forwarding plane and can achieve that inspection at layer 4 and above. Routers of the traditional format are typically the bottleneck when we talk about SD-WAN deployments. Therefore, we need to look at these new technologies, look at some of the new CPU and network processing capabilities. If we take a quick snapshot of where we're coming from a timeline perspective, in 2010, Huawei launched the ARG3, and that was a milestone product for us. It introduced the concept of multiple core architectures as well as multiple interfaces. We fast forward a bit to 2014, and we launched the industry's first ICT converged router. What we mean by that is it had the ability to run things like virtual machines and hence third-party applications. In 2017, we won an SD-WAN Design Award for the AR650. And then here we are today with our next generation of AR series routers. If we look at the global landscape, we can see that Huawei actually ranks number 1 in terms of the growth rate among top SD-WAN vendors. And we're number 2 in global enterprise router market share. At the bottom of this slide, you can actually see some of the major companies that we work with this technology. They include Vodafone, 7-Eleven, Schindler, and etc. So today we're talking about 4 specific product series. The AR650, which is more of an appliance-based device. Then we have the AR6100 up through 6300. And these are more rack-mountable units depending upon the size and the requirements of your site. All 4 of these include best performance in class, and we achieve that by using our in-house technology based around ARM CPUs and network processing. Again, as I mentioned, that allows us to decouple the data plane from the control plane, and we're able to achieve a 3 times performance boost in forwarding. All of these products also allow ultra-low latency performance. We use something called the Phillippi Algorithm that allows us to do large file transfers without the use of TCP, and by doing so, we can get a 100-time performance boost. Anti-packet loss. By using things like adaptive FEC, we can do things in the video and audio space that get around some of the issues relating to frame freezing. I'll talk about that in a minute. And then, of course, these are all-in-one designs. We have simplified management, and they're very easy to use, but they still have that flexibility of having interface cards to meet your needs. So let's take a quick look at our headquarter or our hub solution. That would be the AR6300. This is for maximum performance. Again, it includes all the elements of minimizing latency, and it's really catering to those mission-critical services that you would have in your larger regional headquarters site. It has that same best SD-WAN performance that we talked about that allows us to get up to 2 gigabits per second over the SD-WAN interfaces themselves, and that's quite significant. It has the hierarchical QoS capabilities. That allows us to identify individual application streams, maximize the bandwidth, and make sure that this is the best bang for buck. It also has those 2 key algorithms that I mentioned built in. The first is Phillippi, which allows us to transfer large file formats more effectively, and also the adaptive FEC, which allows us to have no frame freezing when we're talking about video and audio, even when we have packet loss as high as 20%. The next router, which is more catering towards the mid-size or small-size branch, would be the AR6120. You'll notice there's a VW on the end of this designation. The V implies voice, the W implies Wi-Fi. This does have a SIP gateway built in, and it does support Wi-Fi, MIMO Wi-Fi. It's an all-in-one design. It has that same performance that we saw in the previous unit, obviously in a smaller package catering to the size of this, and that gives us up to 600 megabits per second of performance, again, over the SD-WAN interface. It has a high interface density. We have more than 10 fixed interfaces on this, as well as the ability to support 10 gigabit Ethernet. It's still that same all-in-one design and includes those value-added services like firewall, web optimization, and that SIP gateway. Then we have the desktop unit. This doesn't need to be mounted in a rack, so it's very easy to deploy. It's the AR651W. In this particular case, this is a Wi-Fi compatible model. It also has that ability to add additional interfaces through the use of a mini interface card. It has the same SD-WAN performance capability by decoupling control and the actual data plane, and we're able to achieve 500 megabits per second, again, over the SD-WAN interface. This is a very small, compact unit, and it's unmatched in terms of the functionality that it represents, and we even won an IF Design Award for this particular appliance. So I'd like to talk a little bit about the technology behind these products that allows them to perform the way they do. The first, as you're aware, Huawei produces a lot of our own silicon chips in-house, and we're leveraging those ARM CPUs combined with our network processor capability to give optimized performance. If you see in the diagram here, we've decoupled the control plane at the top with the forwarding plane at the bottom. So what we do is we look at the first 1, 2, possibly 3 packets in any application flow. Those are passed to the control layer, where we do things like IPsec acceleration, deep packet inspection acceleration, and we make use of a multi-core architecture application stream. Then we can fast process that down in the data plane layer using things like hardware-based forwarding or hierarchical QoS acceleration. So what are these 2 algorithms that I mentioned? The first is the Phillippi algorithm. What makes this unique is if you can imagine transferring a large file between data centers using something like TCP. TCP has a sliding window algorithm, and it uses things like retransmissions in the case that a packet is lost or a packet is received out of order. What that means is that it's not really capable or robust enough to do large file transmissions and make sure that they're done in an efficient way. By getting rid of some of that functionality and leveraging UDP, which is what Phillippi does, we don't have to worry about out-of-order packets the same way. We can reassemble that as those packets arrive, and we're able to achieve a much significant better efficiency use of that pipe. So if you look on the left side of the screen here, what you'll see is the before. This is using a typical TCP type scenario, where even though you have a 1 gigabit per second bandwidth, because of the latency that's introduced and because of the packet loss that's introduced, the effective file transfer speed is well below what you would expect. And we see here in this particular case study that we did, it was 1.8 megabits per second. As we move to the right side of the screen here and we look at what we're doing with the Phillippi algorithm, we can see that because we don't have those restrictions around the TCP sliding window or the need for NACs or retransmissions, we're able to achieve significantly higher performance. So using that same 1 gigabit per second of bandwidth, the same 1% packet loss and 100 millisecond latency, we can achieve 946 megabits per second of performance. That's very close to 95% of the actual line rate speed. If we look at adaptive FEC, what this allows us to do specifically is for media-related transactions. If we're talking about audio or video, typically what happens is as packet loss is increased, what we actually need to do is introduce more redundant packets. We do that because if packets are lost, we need to be able to recreate the overall video or audio stream. And by doing that, these redundant packets can be repositioned into that actual data. What this allows us to do is achieve nearly zero frame freezing with packet losses as high as 20%. So if again, you look on the left side of the screen, you can see at a packet loss rate of about 5%, we start to see significant artifacting or frame freezing. By using this adaptive FET control, we actually see that we can increase the packet loss rate as high as 20% and still effectively give a seamless video or a seamless audio stream with no artifacts and no frame freezing. So this series of routers, just to recap, it is an all-in-one design. It does offer a broad array of services, and it does give the maximum benefits possible for today's enterprises. It includes the SD-WAN feature set. All of the products that we're launching today have the SD-WAN capability. They can still operate as traditional routers if you do not wish to deploy SD-WAN particularly. It has a multitude of VPN solution capabilities. It has security built in terms of firewalling, URL filtering, as well as intrusion prevention and IPsec overlay, obviously for the encryption of packets. And then, as I mentioned previously, we have those value-added services, as well as new interfaces like Wi-Fi and LTE, or perhaps you want something like a voice SIP gateway. If we look at each one of those individually, first of all, how do we identify the application? We have three key ways we can do that. The first is that for common SaaS applications, things like Office 365 or Salesforce, for example, we can recognize it using the first packet identification methodology. That means as soon as an application starts, we know immediately what that application is and how to prioritize it. For those that do not apply in that FPI model, we use deep packet inspection. And by applying DPI, we can get even more complex application identification. This allows us to identify as many as 6,000 or more unique applications. And then if that's not enough, of course you can customize it as much as you need to by simply doing URL type identification or using the 5-tuple information inside the IP packets themselves. By doing this, we're able to get full visualization of all services from layer 3 to layer 7. Secondly, once we've identified each individual packet stream by application, now we need to be able to intelligently steer that. We have a comprehensive traffic steering methodology that allows us to manage bandwidth based on link quality, application performance. We can do that at the VPN level, we can do that at the link level, or we can simply do that based on bandwidth fill rates. Why we do this is to make sure that we ensure key application performance is maintained in the event of bursty traffic or in the event of congestion. So you can see here we have some examples that we've run through, but realistically we can achieve a bandwidth utilization that was typically 60% and go upwards as high as 90%. If we look at the VPN technology feature set, in addition to supporting more traditional VPN technologies based around IPsec or dynamic smart VPNs, we also support GRE and, of course, client-based VPN technologies. So that could be L2TP or IPsec again. But we also introduced the idea of the extended VPN or the SD-WAN intelligence. That allows us to use the mainstream IPsec encryption algorithms while still providing that secure isolation of data access. The extended VPN or SD-WAN feature set. That includes things like the ability to expand the VPN elastically based on the needs of the enterprise. The comprehensive services that we offer in terms of security include an array of features. URL filtering, we can identify more than 130 URLs today with a 96% accuracy rate. We also have application access controls, and that allows us to identify more than 6,000 individual applications. Based on that, we can modify the traffic parameters, we can limit the bandwidth, etc. We also have intrusion prevention systems that allow us to detect more than 500 attacks 90% correctly. And then finally, we have that data encryption that I mentioned previously, where we're using mainstream IPsec to make sure that the integrity of the data is intact. So if we look at the segments where these are positioned, again, I mentioned there's multiple products here, but you would select this based on the site requirements, usually based on the size or perhaps based on the budget. At the top, we have the headquarter or large site models. That would include the AR6300 as well as the AR6280. This is where you're going to get the best SD-WAN performance. I mentioned before, more than 2 gigabits per second of SD-WAN throughput. For a small to medium-sized office, you probably would look at the mid-sized site. And here we have the remainder of the AR6100 and 6200s. These would include elements of perhaps those VAS services, voice, firewalling, and perhaps an LTE interface. For smaller sites, we have the AR651 series, and that is your desktop appliance. These still give you the flexibility of having additional interfaces as you need. So for example, you can get a Wi-Fi model or you can get a model that supports an LTE WAN interface. All of these products have that same best performance by decoupling the control and the forwarding paths, and that allows us to achieve up to 3 times the forwarding capacity of a traditional solution. They all support the ultra-low latency technology using that Phillippi algorithm that I mentioned before, where we're no longer restricted by the limitations of TCP, and we're able to make better use of the overall bandwidth. They all have the anti-packet loss capability using the adaptive FEC, which means we can go as high as 20% packet loss and still ensure there's no artifacts or disruption to the video or audio stream. And then finally, these are all-in-one designs with simple management. So just to recap the overall solution here, we're talking about a transition from traditional routing into SD-WAN era routing. And what that really means is that we're no longer looking at layer 1 through layer 3. Instead, we're looking at layer 3 through layer 7. That obviously comes with a lot more requirements on the CPU performance, and that's why we've introduced our own ARM processors and network processing. We have that plethora of interfaces that I mentioned in the beginning, so we can support splits for internet, we can support MPLS, we can support Wi-Fi, we can support LTE, as well as all the more traditional interfaces. We have the ability to identify the individual applications 3 ways. Again, we have that first packet identification for major SAS applications. We also have deep packet inspection, where we can identify another 6,000 plus unique applications. And then, of course, you have the ability to customize it if you want using the 5-tuple or URL filtering. We have that application-based intelligent steering. So now that you've identified the application, what do we do with it? We treat it differently based on VPN fill rate or based on the quality of service required for that application. And then we have those 2 algorithms that are really the core that allow this to happen and achieve the higher performance that we're talking about. The first is the adaptive FEC, specifically for media, and then the second is the Phillippi algorithm for large file transmissions. So with that in mind, I'd like to remind you that you can submit your questions now, and as well, at the end of the question period, there will be a short quiz. If you fill that out, you will be eligible for some prizes. Okay, so we've identified what our team here thinks are the best questions, and I will try to go through these and give you some answers. So the first is, what is the usage of an SD-WAN router? Is it a replacement for MPLS, for example, or would it replace a site-to-site VPN topology? Actually, the SD-WAN is more of a technology that's put on top of what you would already have. So for example, it's not a replacement for MPLS. MPLS would still operate at layer 2. And above that, you would have your SD-WAN VPN configuration. So it takes the traditional technology that you have today, but gives you an additional feature set with the ease of management, the elasticity, and the better control elements of what SD-WAN would introduce. It also introduces some of the newer interfaces because, again, it's multifaceted. So you're no longer restricted to just a particular layer 2 technology. Now you can leverage things like an LTE interface or a multitude of other interfaces. How can I get more information online about the AR series routers? Well, you can visit our events mini site, or you can also go to the Huawei website at http://e.huawei.com. That's E for enterprise.huawei.com/EN for our English interface. Is there any specific Huawei proprietary VPN apart from industry standard for SD-WAN? The answer is yes. We do introduce that extended VPN model that I mentioned. And what this allows us to do is reach as many as 20,000 endpoints. So typically a VPN technology would top out significantly less than that, in the order of hundreds of endpoints. But with this extended VPN technology, we introduce larger tagging fields, and that means we can have a network that's as big as 20,000 devices. Does the box have dynamic multipath optimization capability? That's a mouthful. Yes, it does have dynamic link adjustment with load balancing and web optimization built in. So yes, it does. We can identify the unique applications, and then based on that, we can handle it as we need to, whether or not we need to load balance links or whether or not we need to prioritize it over other traffic flows, or as well for web optimization. Yes, that's all included. Is Wi-Fi 5G supported? The answer is yes. So on the WAN side, we would have the LTE as a mobile interface, and on the LAN side, we have the Wi-Fi capability, which is 5G. And for those that aren't aware, 5G is the new nomenclature for what is 802.11ac Wave 2, so we do support that. Which models support LTE? So effectively, all the models support LTE with the exception of the AR651 Lite. All the other ones do support it through the use of either a services interface card or the mini interface card. So the MIC is actually on the AR651, and the SIC is on the AR6000 series. What is the hardware architecture used by Huawei's next generation AR routers? So this is all based around our in-house ARM CPU development. As well, we have specific processors that were designed for network processing only. We combine those two together, and that's what allowing us to achieve the separation between the data path and the control path and get that 3 times performance. How many SD-WAN connection types are there? Well, there's a lot. I mean, if you think about traditional routers and what types of interfaces they would have, it would be DSL, it would be Ethernet, maybe PON, E1, T1, all of those interfaces. And as well, we can do things like MPLS over top of that. So anything that's a traditional layer 1 or layer 2 technology, of course that's supported. At layer 3, standard IP, and then beyond that, we offer all those VPN solutions, whether it's L2TP or GRE or IPsec, as well as the SD-WAN functionality itself. What is the name of Huawei SD-WAN controller? Okay, so all these products actually need to be managed by some type of centralized controller, which is something I actually didn't introduce in the material here. So in addition to deploying these individual products, you would also have a centralized controller that we would call the Agile controller. And this is where you would actually set up the topology, and that's where that ease of management and simplified management interface would exist. If you bought the router Huawei Next Gen AR, are there any other fees to pay? Well, in addition to buying the product, depending upon the functionality that you want, yes, there are some licenses. So for example, if you were just to deploy this as a base SD-WAN router, you would have a particular cost. But if you wanted to introduce things like the firewall capability or perhaps something like the SIP application gateway, that would be factored into the cost model. So yes, there are some features that require you to have a software function license. I believe that's the end of our 10 questions. Just a reminder that there is a quiz at the end. If you submit your answers, those that have the most complete and correct answers are eligible for a prize from Huawei, and we'll reward those offline after the webinar. Thank you very much.